Again, let us welcome in next lecture of MAT-201, that is integral calculus. So in this lecture, we will see volumes and surfaces of revolution. It is chapter number 6. So first, this figure is there. You can refer this figure. So here, PQ, it is a length, it is arc of the curve. You can consider that curve, that is y equal to fx. It is given. So we'll revolve this curve PQ about x-axis. So this is x-axis and it is y-axis. So let PQ be an arc of any curve and AB be a straight line which doesn't intersect the arc. So draw PL and QM perpendiculars to AB. So let's see here. Yeah. So let's draw these lines PL and QM perpendicular to the line AB, or you can consider the line ELM. Actually, it is x-axis and it is a y-axis. It is there. So now, if the curve PLMQ revolves about, so PLMQ, so we are revolving this curve. So let's see. Yeah. So we are revolving this curve PLMQ about the line AB, or about x-axis. So this is the axis of revolution. You can say we are revolving this curve PLMQ about the x-axis or the line AB. Yeah. Then after that revolution, a solid will generate a solid known as the solid of revolution. So the solid which is generated after that revolution, so that solid is called solid of revolution. Uh, this straight line AB about which the area revolves is called the axis of revolution. So it is there. So what is the axis of revolution? And the solid generated by after revolution of that curve. So there is one theorem: the volume of the solid obtained by revolving about x-axis the arc of the curve y equal to fx. Suppose if we revolve the curve y equal to fx about x-axis, intercepted between the points whose coordinates are a and b, or between the ordinates x equal to a and x equal to b. So it is given by this integration, that is integration from a to b of pi y square dx. Means if you revolve the curve y equal to fx about x-axis between the ordinates x equal to a and x equal to b, then the resulting solid generated because of that revolution, its volume is given by this formula. That is integration from a to b of pi y square dx, or you'll write here, that is integration from a to b of pi, because y is fx and it will be fx square dx. So this is the case when the given curve is symmetric about x-axis. But when the given curve is symmetric about y-axis, so in that case, we'll write this theorem in different form, and we'll write it as corollary. The volume of the solid obtained by revolving about y-axis of the curve. So curve x equal to f of y, which is symmetric about y-axis, and in that case we'll revolve resulting curve about the y-axis. So axis of revolution will be y-axis, and intercepted between the points whose ordinates are x equal to y equal to c and y equal to d. In that case, the volume of solid generated because of that revolution is given by this formula, that is integration from c to d of pi x square dy, or equivalently you write it as integration from c to d of pi. It will be f of y its square dy. It being assumed that the arc does not cut the y-axis, so obviously that arc should not cut the y-axis. If that arc cut the y-axis, so we cannot apply this theorem. So again, as usual, I will solve some examples as illustrative examples, and I will give some examples as home. So find the volume generated by the portion of the arc y equal to square root of 1 plus x square lying between x equal to 0 and x equal to 4 as it revolves about the x-axis. So here axis of revolution is x-axis. You are given y equal to square root of 1 plus x square, means fx equal to square root of 1 plus x square is given. And here the yeah, that curve, we are revolving between x equal to 0 and x equal to 4. So required volume is given by integration from 0 to 4, because x varies from 0 to 4. Pi y square dx, y is given, that is square root of 1 plus x. So it will be that is pi. You can take outside of this, yeah, outside integration. So integration from 0 to 4, and root 1 plus x square, its square will be just 1 plus x square, or that will be pi x plus, after taking integration it will be x plus x cube upon 3, and limits from 0 to 4. Or after simplification you will get the required value of this integration, that is 76 pi upon 3. So this is the required value of the uh, yeah, solid, which is generated because of this curve, which is generated because of revolution of this curve, that is y equal to square root of 1 plus x square about x-axis between the ordinates x equal to 0 and x equal to 4. So this is the first illustrative example. Second illustrative example is that find the value of the solid obtained by revolving the ellipse. It is given by equation of ellipse is x square upon a square plus y square upon b square equal to 1, and the axis of revolution is x-axis, which is the major axis of this ellipse. See, so given curve is x square upon a square plus y square upon b square, that is equal to 1. Or you'll write this curve as y square upon b square equal to 1 minus x square upon a square, or you'll write it as y square equal to b square upon a square, in the bracket that will be a square upon x square. So you can refer this figure. So required value, the volume of the solid obtained by revolving the arc a b a dash, means we are just a b a dash actually. So we are revolving this arc. Let us see, that is a b a dash. We are revolving this arc about x-axis, and the solid, because of that revolution, this solid will generate. So we have to find the volume of that resulting solid. So that solid will be, you can just imagine. So it will be volume of solid obtained by revolving the arc AB A dash about x-axis. So this is our required volume which we have to find. So we can write this volume, resulting volume as 2 times the volume of solid obtained by revolving the arc AB about x-axis. So instead of revolving this arc AB A dash, we are just revolving this arc, that is AB. Means half arc, half of this arc we are just revolving about, yeah, about x-axis, means we are just revolving this arc portion of this arc, we are just revolving about x-axis, and because of that, because of that revolution, so half volume will be generated, the required half volume will be just generated. So it will be 2 times volume of solid obtained by revolving the arc AB about the x-axis. And what is the volume of solid obtained by revolving the arc AB about x-axis? So it is given by 2 times. So integration from 0 to a pi y square dx. Already we have y, that is yeah, b square upon a y square we have, that is b square upon a square, square root of a square minus x square. Let us put these values, and 2 pi it will be outside b square upon a square, which is again outside of integration. Integration from 0 to a square minus x square. So you can find the value of this integration, and after putting upper and lower limit, so you get the required volume, that is 4 pi ab square. So it will be the required volume of solid which is generated because of revolution. Actually, yeah, this is nothing but volume of solid obtained by revolving the ellipse x square upon a square plus y square upon b square equal to 1 about the x-axis, that is major axis of that ellipse. So again, there are, yeah, 3 examples for more. Already I have given answers of these problems. We can try these 3 examples at home as a homework. So this is the end of this topic, that is volume of solid which is generated because of a revolution of plane curve. So I will stop here.